Hello everyone, this is Jason Edelman with a quick overview of the Network Control Manager, which is my first onePK application. This is going to be a very brief overview. For the longer version, I would encourage you to go back and look at the full slide deck I put together that can be accessed from my blog at jedelman.com. So right now, again, keeping it brief, we're going to look at high-level architecture of the Network Control Manager. Starting at the bottom, what I have here are network devices. So network devices that are virtual routers on my host machine, and each router has a onePK agent loaded on it. Within the center, what I've developed is something that I'm calling the Network Control Manager. The Network Control Manager is primarily written in the Groovy programming language, which is a very dynamic language. It's based on Java, and the nice thing there is it allows us to be able to use native Java libraries. So I'm using the native onePK Java SDK from Cisco throughout this application. And the overall framework used here is based on Grails, and Grails just makes it very easy to publish northbound APIs. So if we take a step back and look at the blue centerpiece as an SDN controller, we hear a lot about APIs. So in this case, the southbound API is onePK. So from the controller, southbound, we're leveraging onePK to communicate to the network devices, and northbound of the controller, we're communicating with consuming applications or control programs that are going to provide a certain function to the network. And right now, what I'll be showing is the CLI application that's written in Python will be leveraging the northbound APIs published from the Network Control Manager. So because we have a two-tier architecture from applications and controller slash the Network Control Manager, in the future a GUI can be built, third-party systems can be built and integrated here via the Network Control Manager. And that's very important to keep in mind as I go through the demo, that as you see the demo and the CLI interface, the CLI is not directly communicating to the network devices. The CLI is only interfacing via APIs to the Network Control Manager, and the Control Manager is then communicating southbound via onePK to the network devices. So like I said, that's a very high-level overview of the Network Control Manager architecture. For more details, I would encourage you to look at the end-to-end slide deck in my blog that I had put together. And so right now I'm going to jump right into the overall demo. Okay, so right now we're getting started with the demo. Right now we're at a standard Linux bash prompt, and what we're going to do is to launch the user interface into the application. So we do that by going into the CLI Python script, Python application. So we actually see all the elements being connected to different listeners being added to the devices via onePK in the IDE screen in the center. We also see that I already changed the network name instead of the host name. So again, this is the start of thinking differently about the network, where we think of it as a network system versus host name is being managed device by device. Very quickly jumping into this, we're looking at two CDP neighbor tables on both router 1 and router 4. So imagine doing this multiple devices. You'd be hopping around on the network. So right now we go back into our network-wide CLI user interface, and we do one command, show neighbors, and we very quickly look at router 1, router 4, and router 3, and all the neighbors associated to each one. So very quick. You don't need all the additional output on hold times and capabilities of the devices. If you want, that can be added into the output of the show neighbors command. But right now it's very quick and again very efficient to view that. And we can also look at other attributes like show serial number. And again, we go very finite and to the point, very granular in what you can view here. So these are just some examples. And it's also very, very slick that multiple keywords can be combined in a single command. So now we do show serial number and neighbors on the same line, and we look at the neighbors and serial number for all of the routers in a single command. And the nice thing is we can even add more keywords like CPU. So now we're looking at 3 keywords in one command, and the limit isn't 3, it's really limitless, and we can add different things like interfaces and recent command history we'll see in a few minutes. But again, this is just a quick example on the power of viewing it as a network system versus a box by box management paradigm. So again, real quickly mentioned here, show command history, shows CDP neighbors because we executed that previously. Right now we're going to show two more commands, show clock, show running config, and in the IDE output in the top right, we actually see events coming into the system, and we see the events being processed. To view that in real time, we execute the command again in our CLI, and we could quickly see the commands already there. And again, just to show the power of the keywords here, we can now add serial number back in, and now again it's in real time, it's dynamic, and we see things as they happen on the device in the CLI. And the CLI again is decoupled from all devices, and this is running independently. We can also do show network all. So right now we have about a dozen attributes, a dozen keywords defined, from CPU utilization, device summary, serial number, system uptime, total memory, free memory, and all of these can be used as keywords, or you can use the show network all commands to view everything together. And right now we're going to view show interfaces. This one has a lot of output, so we see router 1 interfaces right now. We see router 4 being processed right now. We see router 3. And right now we're showing the IP address and link state for each interface. This can also be added in the show network all command, but I typically don't want to have that in there because of all the output that is being displayed. So at this point, we want to show we can make changes and not only use onePK to extract or retrieve real-time data. So in the top right, we're showing Ethernet 1.1 on router 1. Currently has an IP address of 10.10.10.1 in an up state. So if we go back into our CLI application, go into configuration mode, and do interface router 1 / eth1 / 1, very powerful. If you notice, the host name of the device is being used as an attribute of the interface. This is almost like a chassis-based switch, so we can get real granular. And imagine making changes to multiple devices. You have to log into each device, username, password, and whatnot. But what we just did there is change the IP to 1234 from our central onePK application through the CLI user interface. So again, very powerful, very efficient here with being able to make changes from a single common location, not having to log into each device. So right now we go back into router 1 eth1 interface, and we shut it down, and we quickly see that the interface goes to admin state down. And this is no device by device management. Ideally, we're really not going anymore device by device, and we can manage the network from a network-wide CLI like this. In closing, I would like to just say if anyone has any questions, any comments on what you've seen, feel free to email me, DM me on Twitter, contact me however you'd like. I'm definitely open to feedback and looking for improvements across the way. And as time goes on, as onePK comes out and is fully public, I would love to really expand on what we can do with something like this industry-wide. And that being said, I cannot forget to give a special thanks to Nitin Khanna. Nitin and I started communicating over Twitter and email a while back, and then most recently we were talking again, and we just sort of collaborated on the Python CLI UI for the Network Control Manager, and Nitin put together the first version of that, and so just a big thanks to Nitin. And I really want to close with just saying there's a big talk in the industry on what network engineers have to be able to do within programming, and there isn't really a requirement to do anything just yet. But what I want to say is, if I can do this, you can too. I'm a traditional network guy. CCIE, got it years back. But over the past few months, I really have to say, diving into software development and different programming languages like Java, PHP, Python, Groovy, the Grills framework, all these things, it's just a learning process. And what it really comes down to is time, where just as somebody who has a CCNA or CCNP or beyond, there was time put into study to learn that material. And all that really takes is the same amount of time or the same amount of dedication to learn something new. And going forward, it's just a matter of picking a task or picking a project and going after it. It could take 4 hours, it could take 8 hours, it could take a few weeks. It doesn't really matter. That if you have the desire and have the want to try to tackle something in the programming world, go for it. And I know I've learned a ton over the past few months, and it's extremely humbling because I still feel like I don't know that much in this world. But as you can see, things are coming along slowly, and all it really takes is sort of the idea to try to build something, and then from there, hopefully, something good comes out of it. So, thanks for watching, thanks for listening, and hopefully, I will have more for you in the next few weeks and few months. All right, until then, thanks again.